Okay, I tried to set up a better camera angle here for the wiring. It's a little easier for me now. It's kind of out of my way, but probably just gonna let the camera run, not talk too much here, and let's get to it. I'm gonna start with the track power wire, or the harness rather, for the track power and the motor power. So these connectors are keyed. Just gonna go to the small one, right? And doesn't matter which wire goes where, just whichever one fits best, depending on how you have the board mounted in the chassis, with respect to the shorter wire being closer, right? All right, these are going to go to the pickups. I want to make sure that these wires are not pinched here or rubbing up against the frame. I'm going to do a continuity check, make sure nothing's shorted there. Mainly, I'm going to check the insulator on the center rail. Center out screw rather, make sure that it is not touching the frame. Alright, looks good. It's good. Alright, let's isolate it. Let's see how this fits. In the beginning I mentioned we would come back to this part. So this is something I usually save for when I'm doing the wiring, where I'm at now. We'll grease these gears up later too, because I'll probably have these motors out once more. I don't want to get grease all over the place. Alright, so at full scale turn, I get some rubbing here. I know I don't have any extremely tight radius, and I think even on 031, I don't think it's going to hit that far. So we have some insulation on there, but we're going to bend this back a little bit over the screw. Kind of make sure that is as straight up as possible. Yeah, and we have clearance there, so it's not hitting the blue wire. You don't want that chafing either and hitting the frame, but that one's not going to matter so much because it is the chassis ground off of the two side rails. So this looks good. Got a nice little bend in the wire. I don't like putting 90s in them. This has some heat shrink on it already from the factory, so usually I put my own on, and I think I'm going to do that anyway. We're just going to try to pull this one up a little bit, even it out. There we go. Oh my God, it looks good. Okay. All right. And the coupler wire looks pretty good too. It's got a little rubber insulator over top of it, so I'm not too concerned with any chafing down here. Again, when it's riding on the rails, we'll have clearance. It'll be something like that, so I think we're good there too. But this one, I think I'm going to bend this down a little. Again, I really shouldn't be using metal on this, but that's what I have right now. And it is the chassis wire, so I'm not too concerned with that. Alright, that one looks good. Okay, that spins freely. Let's move on to the back one. Check these wires, get them set up. I want to pull that insulator up a little bit, if I can. Let's just put the motor in, double check it. Okay, that looks good in there. Just wanted to have this rubber boot up a little bit past this edge here, so the coupler wires do not get chafed on the frame. And again, that's full scale, and we're going to pull that up a little bit more. We're going to pull it up a little bit more, just so it has a little bit more coverage on that edge if this were ever to see a full scale turn. Yeah, that's why I didn't tighten that up all the way, just in case we had to move it. Just move it up a little bit. Alright, crank that down now. Make sure that these coupler wires are not tight. I'm going to have some play on them, some service loop. So as the coupler moves, we don't break the wires off, resulting in a short to the frame and bad things happening to the board. So, looks good. Alright, that's better. Looks good. Looks good there. And that actually provides a little bit more insulation too for the center rail. If this were to go full turn, we're going to bend that up a little bit. Make sure it doesn't pinch the wires. You don't want to go too far because these can break off if you go back and forth. So I'm going to make sure you got everything positioned where you really want it, and then just give them a gentle bend. All right, I'm happy with that. It's not bad back there. I'm okay with that. Actually, give that a little bit more loop. Tighten that one up. Alright, that looks good. I'm happy with that. It's good underneath. Clearances all look good. I should have checked this one while we had it off. Would have been a little bit easier. You can also use the wires here too for continuity checks, so we can do that. I'm just going to put this over here. I'll double check these, make sure that they're isolated. Good. Nothing there. Yeah. Okay. That's good. last time. Alright, we're good. Now I'm actually going to spin this, make it a little bit easier to wire since we're wiring on this side. And for me, this is where the arrows come in handy, especially if I'm doing this late at night and get which way's forward. Again, not that it really matters at this point, but it's just a nice to have, nice indicator, quick reference where you're at. This is where I begin to use a lot of tape to start tacking down the wires. I want to keep a good service loop on there, just in case we have to cut wires sometime down the road. I don't know. It's always nice to have a little bit extra on here. It just dresses the wires in nicely too. This shell's pretty forgiving, so there's enough clearance up in here to bundle the wires, because we're going to have a big bundle of wires right up in here when we're all done with all the lights and everything. And you also need to have service loop on it for when the motor's turning. So we need to have some excess up in here. And I think I'm going to put on the front shell here. Yeah. What is this, a light diffuser? The cab. This is going to help me with the wire management, as long as we have all the pieces in place, all the major parts. It's just going to help me figure out how I'm going to wire it. Again, this is going to come on and off probably a few times, so just to help me picture where everything's going to be, how it's all going to line up. There is no special technique to this, but you do want to keep your wires as clean as possible. So this will help me keep everything in a line or lined up, so that when we go to zip tie it and bundle it all together, it's routed nicely and dressed in. I'm going to put a bend on that. I'm going to hit that with the soldering iron, heat that shrink tube up and form it. Alright, my personal preference is to cut these off and go individual wire to individual wire. So that's what we're going to do here. You don't have to. You can tie them all together. So in this case, the orange is the center rail. These are going to go to the red, and then the blue wires are going to go to black. So let me get this one dressed in a little bit, get an idea of how much we need to cut off. You want to keep the wires as short as possible, just for wire management mainly. But again, you do need to keep service loop in there as well. Use the fronts, use the backs, and that's about where I want these wires to land. So we're going to keep them all together, and we're going to keep these all about the same length. Make sure that you have enough service loop here, so that as the trucks move, the wires don't get pulled tight. Yeah, these don't all have to be perfect length. I just try to get them as close as possible. Alright, they look good. I'm going to take this out. It's just easier to strip these wires with it. Alright, once stripping these, you want to make sure you're really holding that wire tight if you're going to cut them short like this. I've had some that do pull out of the connector. They're a little tough to get back in. So we're going to try not to do that. This one doesn't want to stay on, huh? Reuse tape. Alright. It's not as sticky as it once was. It's alright. It'll work. So let's double check this again before we solder it up. That looks good. Alright. Do this. Alright, get some heat shrink. I'm using 1/16 heat shrink. And we're going to cut a bunch of these little pieces off, about an inch or so. Get 4 of these. These do not matter which ones you use. Which red, there's 2. Doesn't matter which one you use. Same with black. Touch this one up a little bit. And just do a continuity check. Now that's just the board resistance that's sitting there. As long as it's not a direct short, you're good. Like that. Alright. Let's pick some spots here on the frame without too much paint on them. Let's go to the screws. Just double check again. Alright. Good. And then these are going to be good too, because we already checked this. Alright, it's good. Alright, so they're isolated. Now we'll move on to the motors. Okay, so I kept the yellow wire on the motor. And that was to remind me where to put these now. The PS1 unit had a blue one on it for the other side, but it doesn't matter as long as you keep this same color on the same side. Let's start with the yellow. Actually, before we do that, we're going to put the heat shrink on here. It's a little sharp there. We're going to flatten that out a little bit and straighten out the solder joint. Alright, looks good. Alright, let's get this first one on. Try to put a nice little bend in this. And the way the wire is going to sit, it's going to be like that. locks it in. So it's easier to heat shrink this with it not plugged in, but I like to do this so I can form the wires here. So I like to do it with it in place. Just gonna bend that one out of the way. Try to do a nice gradual bend. This is where I start using some zip ties too. I'll start holding the harness together as we form it. Alright, so that's the main wiring. We got the rail power coming in off of the pickups, off of the power trucks, and then coming up into the circuit board connector. And then we have the motor wiring in. And again, it goes back to the same wiring harness here. So now we can get onto the, I think we'll go to the smoke unit next. So we'll get the wiring harness out, the main harness. Gonna have a lot of wires all over the place, and we'll start peeling back the layers and getting in the smoke unit. I think first I'm going to do this a quick service on this. So that's what it looks like inside. Looks like the batting is just pushed in there. I guess that's how they did it from the factory, maybe. I don't know. Maybe somebody tried to replace this at some point and just jammed in it, but you can see it's burnt. So we're gonna fix that. Yeah, these don't look bad. I'm not going to worry about these. I'll do a quick measurement on them, check them out, make sure they're not shorted. The gasket's not cracked. I probably should replace it, but I don't know if I have any more of these in stock, so we're just going to go with this one. So these are the replacements that I use. It's a thicker wick. I think I get these off of eBay. Trying to remember if, I don't think these are MTH replacement, direct replacement. I think the ones you get are more like this. I could be wrong though, so if you guys know better, leave something in the comments. Alright, so let's check the resistance of these. I think this unit was already out of a PS3 unit, or PS3 model. It was a smoke unit I got off of eBay, and these are already in parallel. You can tell by the solder on both of them. So both of these resistors combined in parallel should be 8 ohms total, and we could just take a measurement right on the top side here. Each one's going to be 16, I believe, and then in parallel they're going to be 8. So got a glare on that. There we go. It's not much better, but anyway, we are at. If I can get on there. There you go, a little over 8 ohms, 8.1, that's good. So, these elements are okay, as is. I'm not going to do anything with them. I'm not going to try to clean these up or anything either, they look okay. In one of my previous videos where I showed the smoke unit repair, or rebuild rather, these resistors, these heating elements are really gummed up. I mean, these have some stuff on them, but it's not bad. So I'm not going to mess with them. Just going to put it back in. Alright, so I like to take the wick here, put it in about even between both of these. You want to have an air gap up in here, because what happens is the air that the fan is pushing through out of the chamber there comes out across this element, and I'm sorry, between the wick and element and the top of the top cover of the chamber. It goes out the hole right there in the smoke unit. So it's a little tricky to get it in there. I don't think it needs to be perfect, as long as you have some air movement over top. I think we're going to do it like this, because we'll get air moving around that. I'm going to start over here. I'm going to take that, kind of pinch it, twist it, like that. Give it a couple twists. There we go. And you can see we got air that'll move around that. So this is the tricky part here now. Jam all this back in here. Try to keep that, maintain that twist. Get all the pieces in there. Now, I can't really see this, but I'm forming a hole at the top as best I can so that we can get air around this. Right. Alright. Gently put it in. I'm just checking it as I put it in all the way around. Alright, I'm gonna very carefully just kind of poke this down through the hole. Take another look. Yeah, we got some air gap, which is good. So if you have that wick all the way jammed up against the top of the chamber here, you're not going to get any air moving, and you're not going to get much smoke output. Just get one of these screws in here, get it started to hold it in place. Gently put those on. They're not tightened down yet. Alright, let's check out the motor on the smoke unit. Take a little look at this. So as you can see, we got these impellers in here, and they have a pitch to them, which is like this. Hard to see, but they go that way. Now the fan, you want that to rotate clockwise. Even though the blades are not pitched, you would think to blow the air out. I believe that is for noise reduction. It was designed that way. So So you want that impeller to go clockwise to make sure that the air comes out of this opening here and then goes into the chamber and across the wick with the oil, saturated oil, heat it up, and that's where your smoke comes out. So let's check that out with the battery. I keep an old 9-volt battery around. It's not full 9 volts. I forget what these motors are rated at, but I put this on for a couple seconds. It's never going to, I've never had any problems with it, so I don't think it's going to hurt it. But again, when we have the polarity correct, the air is going to come out of here. It's going to come towards the camera here. When we get the polarity correct, and that way we know which of these is positive. If you have a situation like this where you don't know what the polarity is, you got it as a donor part. If you're replacing an existing smoke unit or wiring to a model that has the existing smoke unit, it should have the correct polarity on it. So let's give this a shot. Let's just see which way that's going. It's kind of hard to tell, but put my finger over the hole and I'll turn it the other way. I'll put my finger on to slow it down too, but yeah, that's going the right way, the correct way, and I can feel the air coming out of the slot there. Let me just spin it the other way. Yeah, that's going counterclockwise that way. So we don't want to go that way. We'll go this way. All right. So we'll mark our positive side. Again, just do a last check. Yep. So this one's positive. So I'll take the old Sharpie, mark that off. Big old plus, can't miss that. I'll do a minus over here. There we go. I'm going to try to clean up these terminals as best I can before I put it back on. So it looks like it's got a little flux on it from when it was last soldered on. I don't have any alcohol with me right here, otherwise I'd clean it up a little better, but let's just tin it. Get the terminal tinned up. You don't want to keep the iron on this too long because this is a small motor with a little plastic cover on the back, so as you can see, I think it just melted a little bit. I just want to cleanly tin those, and I like to hit it with some air, cool everything back down. Also, you want to be careful if you turn these upside down. It will freeze your finger. Alright, that looks good. Now, I like wiring these before I put this back on, especially if the smoke unit's in the chassis already, because trying to get down here on these little terminals is almost impossible to get a really good clean solder on that. So let's go to the let's get out the wiring harness kit next. Okay, so we have the main wiring harness here. We want to use, let me find something to get in there. Use these two green wires again. I know I should not be using a metal object for this. I'm doing it very carefully. Wooden toothpick, something to poke around the wiring harness is always better than metal. So we're going to use these two greens here. This is all in the wiring diagram in the manual as well. I've done these quite a few times. I know where they're at. So we want to take these two green here, and on the other side there's a gray right in here. Okay, so we got these out. Now at this point I'm going to plug this into the board and then try to begin routing these wires to follow this harness here. So I always try to use my main power and motor wiring as much as I can to start the trail of how I'm dressing the wires in. Sometimes I have to go on the other side, but it just makes for bundling up the wiring harness a little bit easier. So we'll see how this one falls. We may have to go on the other side, but actually before we do the motor wiring, Just want to talk about these two black wires here at the top. So the wiring harness, let me spin this around again. Let's get a better view here. So as the schematics laid out in the instruction manual, this is the top. This is the top of the connector here. It's going to plug in. Again, this is keyed, so it's only going to go in one way. But these two wires here, this is to allow you to select between DCS and DCC, depending on what you're running. 3-rail, I think, could be wrong. Again, tell me in the comments. It's always going to be in DCS. That's how I run all of mine. So what I do is I just take these two wires, cut the switch off, and short these two together. And that will always guarantee that it's in DCS mode. So I like to take it out and do this. Get a nice clean splice in there, connection. I just like to leave myself enough room to work with when I do this, not make it too short. Put a nice little loop on it. Alright, there we go. There's the loop. So now it is always in DCS mode. There we go. So let's plug this into the board now and see how this all falls. When I'm doing this, I think I take that back. I probably don't try to route these over here. It really depends on the model, and you know, because you got to remember you have to fit the shell over this. So depending on how big of a bundle you're going to have here, right? It's gonna pinch this bundle down. So you really want to make these wires flow nicely. All right, so maybe we will go this way. Let's see. Let me put the motor on. See where the wires fall best. So the plus is going to be on this side. So we can wrap them around like that. I think we're going to go this way. It will make getting the connector off easier if we have to. If we have to take things off, this connector can come off this way and that connector can come off that way, and you don't have that bundle over top. But again, it really depends on the model. I've done so many of these, I can't remember if I really have a preference. I just do it the way that it fits best for that particular application. So what we're going to do, I like to leave some service loop here. Just put a screw in here temporarily. Kind of hold things in place while we tack it down. Like I said, I use a lot of tape on these, so try to reuse the pieces because it's only holding things in temporarily. I'm always trying to keep in mind how this wiring bundle is going to sit once that shell goes on. So usually I do try to fill this area in here with the bulk of the harness, of the service loop of the harness. So I'll leave some slack on there, and then that's going to come up like this. Probably want to wrap it like that. And these two green wires get twisted together. These units can handle 2 smoke units. The PS3 controllers rather can handle 2 smoke units. So which is why they give you the extra wire here. Really don't need to strip much off of these. You could probably almost get away with just tinning the very edge of it through the insulator. I think I've done that before too, and it just puts a tiny little blob of solder on the end of it. That's all you really need. Alright, I like to hit these with a little bit of hot glue once we're done. Just a little bit. In between these, the motor, air chamber, and the smoke unit, heating element chamber, there's a gasket in there. You want to make sure that that's in place. what I found usually is they're RTV'd in there, at least to one side, and it's typically the chamber side. Sometimes if somebody's been in there before, they'll RTV both sides and the whole thing comes apart when you separate them, but you just want to make sure that that's in there. And before I tighten this up, I like to press on this in that direction, because there's a little bit of slop in these screw holes here. I want to make sure that we get a good seal there, otherwise you're going to have smoke coming out or leaking air, and you're not going to get the smoke output that you can be getting. So we'll tighten them up pretty good, snug them, and then a little bit more. You want to over tighten. Again, there's a gasket in here. We don't want to compress too much. I think it's just like a cardboard. And again, we're gonna tighten these up, and while squeezing this, at least this is how I do it. We got our wires on there for the motor. Next we can wire up the heating element. So we're going to use these two brown wires here, which are pins 8 and 10 on the main connector, and then we're also going to use this blue one here, which is 14 on the main connector. So we're going to route these around the same way. This particular smoke unit has two little soldering pads already allocated for wiring up to. If you don't have those, you can wire directly up to where the resistors are soldered into the board. It's the same thing, so it doesn't matter. And there's no polarity on these as well. It doesn't matter on this. Blue can go on the left or right, and same with the brown. Okay, so we'll move on to the coupler wiring now. So we got the front coupler here, which is blue and brown, which is pins 12 and 1. This is pin 12. 12 branches off into 2, so it goes to the front and the back. The front coupler again is going to have the brown wire, which is going to go to pin 3 on the connector, and the gray one here will go to pin 4. This is all in the manual, in the wiring diagram. So when it comes to this part now, really getting into the wiring, I get just the way that I do it. I get particular about it. So I'm going to wind up cutting these anyway to length. This one's going to go to the front coupler, which is this wire over here, and the back one's going to go to this one. So as you can see, there's a whole lot of wire here. I like to shorten these up. I put these nice little coils on here so that gets a little bit of flexibility and recoil back into it as the truck turns, because all this is going to get tacked down nicely, so when it's all done and bundled up into a wire harness with zip ties. So I'm going to cut these. I try to split the difference, so if I know I'm going to have a connector somewhere's about there, try to split the difference for the heat, so to allow for the heat shrink to be straight there, even though we can form it. But I'm going to cut it right about here, I think. Give it a little extra. So I'm going to cut those right there. And now take that excess out, and now we're going to piece this back together. And at the same time, I can unravel this from the harness now and make it really lay in there nicely, because this will all get zip tied right here when it's done. Alright, we'll move on to the front coupler. Before I go any further here, this is where a twist tie really comes in handy. You can, if using a zip tie, just leave it a little loose to kind of help keep the harness form there. If I had a twist tie, I could loosen it each time, add the new wire, and tighten it back up again without having to waste a zip tie. And this front's going to have this around here anyway, so it'll help guide the wires a little bit. We'll have to make some adjustments on that as we go. So we get the front end buttoned up more, but for now it looks good. All right, couplers are done. Okay, so next we're going to wire in the potentiometers for the smoke control and the audio volume control. So I pulled these out of the harness, and we're going to use these 3 wires going back to the connector, which the purple one is pin 19. The audio volume is pin 17, and the smoke volume is pin 15. So where I usually put these is up on these existing switch holes in the frame. There's 4 of them typically, sometimes 2. They're in different locations on different models, and this particular one has the 4 options. Before we pick which ones we're going to use, I always look at the shell to see what kind of space we have to work with. So it looks like this hole over here is covered by the shell when it's installed, or pretty darn close to it, so that one's not an option. And this one we could use, but what I'll probably do is, looks like the front ones should be good. It's going to be these 2 here. We have enough space up in here for them. These only matter in conventional mode, possibly DCC. I don't know, I've never run DCC with one of these before, but in DCS mode your volume is controlled by the handheld. So again, these potentiometers here are mainly for conventional mode, and I labeled these already, just an S for smoke and a V for volume. So it doesn't matter which side you put them on, whatever works for you. One thing I just want to make sure that I mention is, again, be careful of your clearances and make sure that you have enough room to screw these in and wire them. So these little potentiometers just sit right on top. The installation kit for the PS3 upgrade does come with a spacer that'll fit in here, so we can screw through and tighten that up, and you'll be able to access that from the bottom. You'll be able to get a small screwdriver in there. So it'll be something like that when it's all installed. So you'll be able to get a screwdriver in there to adjust those volumes. Okay, let's get into this. So in the kit you'll find these screws, these nuts, and these spacers. I almost used these earlier for the board mount assembly there, but you got to use what you got. So anyway, these are really for these here. So it's a good thing we didn't use them earlier, but there's spacers. Okay, so we're gonna have to drill these holes out, one here and one over here, to fit these 2 potentiometers. Well, to fit the screws for the 2 potentiometers. So we're gonna have to open them up. Probably use a 1/8 drill bit on that. All right, so I have this area taped off. I don't feel like taking all of this apart again, so I'm just gonna tape it off as best I can to eliminate any chance of getting metal shavings into areas where we don't want them. Alright, fits in nicely. Alright, let's clean this area up and do the other side. So now that we have both holes drilled out, we can go ahead and start putting this together. I'm going to put the volume potentiometer on this side. Get the screw in there, spacer on, potentiometer, and get a nut on there. I'll put a piece of tape across the trucks here so we don't nick those up. Okay, so as you can see, you can get your screwdriver in there to adjust the volume. Looks good. Let's do the other side. So you can see this board wants to bend a little bit. These spacers are not exact. I guess you could shim it with a washer if you want, but I usually just snug this up. I haven't had any problems with them. Everything seems to stay put. Alright, we got these 2 mounted now. go ahead and start cleaning up this wiring now. What I'm going to do is shorten these wires, so the same way I've done the others, we'll try to dress these in nicely, take a little bit of slack off them, see how things fall. I may wind up putting a little surface loop up here, maybe something like that, just to take up the slack. We'll see. Alright, let's get into that. Just want to make sure that these two pads are isolated. Try to put that somewhere in the middle, take a measurement. Alright, got some resistance there, which is good. It's not a direct short. Okay, looks good. Just going to try to vary the resistance while I was on there, but I don't have enough hands. Just go full scale on this, both directions. Alright, so it was around 10K in one direction, and probably close to 0 the other side. Yep, looks good. Alright, we'll put it somewhere in the middle. Should be around 5, if I can get this in the middle. Somewhere's around there, so 5 or 6 is what I'd expect to see here. In the middle, rough middle. Alright, close, 4.8. I'll take it. Alright, that potentiometer looks good. Something I like to do here is put a little bit of hot glue on there. You know it. This stuff goes a long way. Alright, let's spin this back around now and get to the tachometer. So now we're ready to install the tachometer. I've pulled that out of the harness already, and it's going to look like this. Got a little chip on here that reads the bars on the motor, which is the tach tape as it rotates. So what we need to do before we put this in is I'm going to get the tachometer tape applied to the edge of the flywheel here. So the first thing you need to do before you put anything on there is measure your flywheel diameter. So I usually use my micrometer here, zero that out. Just around 30 millimeters, so 29.83. So then you want to go to your tape here. The closest thing we have is 30 millimeter. If you don't have a micrometer, MTH gives you these little strips here. You can pop these off and use these as a guide. And you just want to stick them across the top, get a rough, make sure you're centered, get a rough idea what your diameter is. So with that on the center, and it's a little bit over, but that's the closest we got, so we'll have to work with it. And just like the instructions say, you want to stick this empty area on first. You want to start winding it around the flywheel that way. Now before I do this, I did clean off the flywheel here with alcohol, so you want to make sure you get all the oil, grease off of that before you start wrapping this. And I'm going to try to center that on the flywheel as best you can. We're going to rotate that slowly. And I'm just watching the spacing of the brass flywheel on the top and the bottom as I install this, so that way we make sure it stays on the flywheel. Alright, and then when we're done, it's going to look like that. Go all the way around with it. Push it down and make sure it's on there really, really well. Alright, looks good. Alright. And that's what's going to tell the tachometer how fast the motor is spinning. So now, a little slot on the top of this, up in here. You want to drop that tack down into there. Gently pull the wires out a little bit. Make sure that the tack reader, just clean that off a little bit. Make sure I don't have any fingerprints on there. Probably doesn't matter, but make sure there's no oil or grease or anything on there. And that's going to slide down in. And there's a distance that the sensor should be to the flywheel. I believe that's in the manual. Off the top of my head, I don't know. I don't want to give you the wrong info. You'll have to take a look at that yourself. But from what I do know is, from past experience, you want to have this sensor as close to the flywheel as possible. So I did have to swap out this retainer because in the beginning I put in the smaller one. I'm sorry, the narrower one, which would actually, this part's narrower. The sensor, the tachometer was actually too close. It was hitting the flywheel, so I had to swap it out for this one with the wider spacer in it to set it back a little bit. So you may find you need to have to do those adjustments as you go. Now these wires here, we need to make sure that we get full scale turn out of this when we have to. And I'm going to shorten these wires too. So it's going to come around like that. In the past I've taken these wires off the tack and resoldered them on, but you know what, I think I'm going to do it a little different this time. Before I do this, I want to take a look at how I'm running these wires. I may actually run these wires the other direction. I may actually go this way with this and track with the motor wires. Probably do want to keep these tack lines separate than the motor wires just to reduce picking up noise on them, but I think I'm going to do this. Otherwise, I may have these wires bunching up right against the heat sink here, so that's why I'm wrapping them this way. I think it'll be okay. There's a little clip right here that'll hold these wires in, so we may actually be okay this way. And it'll help keep the wires shorter too, which is always a good thing. Now I'm bending the little plastic piece out of the way, doing my best to make sure I don't pinch the wires. Moving these very carefully. Alright, you know what, I think we'll be okay that way. Let's do that. Alright, so before I go any further, I'm going to put a little bit of hot glue on that. Alright, that tightened it up really nice. And we have a clearance in here. Alright, looks good. Now we'll cut these wires here, get these sized up nicely. And we want to make sure we get full range here when we turn. So what I might do is leave a little extra in here, and I'm going to wind these up, give them a little coil like that. Got enough slack right here now. The shell's on, that'll stop when it hits the shell. Alright, looks good. I think we're ready to get all this dressed in now. Now the rest of this is all for the lights and the shell. Actually, I do have one more thing to wire up.